Hello, thank you for joining us. My name is Aaron Rennick, and I'll be your host today. Seepex is a progressing cavity pump manufacturer located in the great Midwestern state of Ohio. Our company was founded in 1973. Today, we are the largest PC pump company in North America, as well as a powerhouse in the global marketplace. More than a manufacturer, Seepex is a process solutions provider. I have had the pleasure of being a Seepex employee for 25 years. Today I'm a sales director for the company, but I have held positions in assembly, production, and engineering. In this presentation, my colleagues and I will demonstrate: how does a progressing cavity pump work? What pump applications are PC pumps suitable for? What are the features and benefits and operating characteristics? The ease of maintenance of a PC pump, as well as covering the many reasons why to choose a progressing cavity pump. Now, I'll pass this on to Chris Brooks. Chris?
Hello, my name is Chris Brooks. I'm a territory sales manager for Seepex. I cover Georgia, Florida, Tennessee, North and South Carolina for the company. I've been associated with Seepex now for about 19 years, primarily in the sales role. I've got about 30 years experience in the pump industry overall. Today we're going to talk about progressive cavity pumps, or commonly referred to as PC pumps. A lot of good features and benefits from using a PC pump. And so we're going to talk about how they work, some of the applications you guys may see in water and wastewater, and then just some of the individual components and benefits. So what is a PC pump? How does it work? So it's a positive displacement pump. It actually is comprised of a pumping element that has two main components, a rotor and a stator. The rotor is the rotating portion of the pumping element. It's typically made out of a steel or a metal material. The stator is actually an elastomer. It's the stationary portion. It's made from elastomer, typically like a Buna or EPDM or Viton. Those two components go together. They actually form a cavity, and as the pump rotates, the cavity spirals from one end of the pumping element to the other. So you can say that cavity forms. As the pump rotates, it spirals. It actually progresses down the length of the pumping element, which is why it's called a progressive cavity pump. There is a compression between that rotor and stator, and that does a couple of things. It helps form the cavity along a seal line and prevents a lot of slip or product from the high pressure discharge side back to the suction. So it kind of traps that cavity. As it rotates, the cavity spirals from one end to the other, and the product comes out the discharge. Really, why are PC pumps used, or where are they used in water and wastewater? The two primary areas are chemical addition or chemical metering, and then sludge handling. There's not a lot of pumps available in the market today that can handle a wide range of products like that. So you can consider we do a lot of polymers, sodium hypochlorite or bleach, sodium hydroxide, caustic soda. So we do a lot of these thin metering chemicals, and then we also turn around and we do dewatered sludges, cake coming off a belt press that could be 45% dry solid. So it's a pretty unique pump, and then it can handle such a wide range of material like that. Okay, the next area we want to talk about is maintaining progressive cavity pumps. A lot of people want to know, are these pumps difficult to repair in the field? They can be. Some of the larger pumps have extremely long stators, so they can be pretty heavy. Also, you have to allow for enough room on the discharge side of the pump to remove that stator off the end of the rotor. Many PC pump manufacturers now have a type of maintain in place component to their pumps. And this means you can actually go in, change the stator, sometimes the rotor or other components, without having to remove any piping whatsoever. That seems to be pretty common among most of the major manufacturers now. The maintain in place actually speeds up the maintenance time. So to change the stator, the times to do that are greatly reduced compared to a conventional stator. Because you don't have to remove any piping and have a spool piece on the discharge, the floor space requirement's much less with the maintain in place designs. Some of the designs also include an adjustment on the fly. So basically you could go back, retension the compression between the rotor and stator as the stator begins to wear. So instead of having to run until you see a performance drop off, change the stator, you actually, when you see that performance change, you actually go in and retension that compression and the pump's back to like new condition. What are the benefits of using a progressive cavity pump? Why would you use it instead of other technologies? One of the main concepts is the compression or the interference fit between the rotor and stator. This limits the slip or the product going from discharge, the high pressure side, back to suction. So it's a very efficient design. It actually is very repeatable and accurate. So we trap that liquid in the cavity, and once that cavity is full, we know what that volume is. So as the pump rotates, we're going to get a known volume per revolution. So by doing that, we can be very accurate in metering. We can also just by changing the speed of the pump, change the flow rate, even at very low increments. The PC pump is also a very low shear device. It doesn't put a lot of shear into the product, so liquids like polymer are very easily handled by a PC pump. Also, if you had a product that had solids that were brittle and you didn't want to break up, like yogurt with berries, for example, you could actually pump that without doing any damage to the berries. The pump can handle large solids. Some of the designs can handle solids as large as 4-inch. The pump can be self-priming. So if you had a below grade tank and you needed to pull liquid from below ground up into the pump, you could do that with a progressive cavity pump. They're very low net positive suction head requirements. So if you had a tank that had a very low level or a long section of suction line, you can actually use these pumps in those applications. We do single and multi-stage, so you can actually get very high pressures out of these pumps. They can also operate on very thin liquids as well as very high viscosity liquids. We pump everything from water or alcohol, which is very thin, up to dewatered sludge cake. Pumps can also operate in either direction. So the normal suction is coming in at a 90-degree angle to the pump. The discharge is out the end. We can actually reverse rotation to where the suction is coming in the straight component. A lot of times if we're pulling a suction lift, we will actually run the pump in that direction so the seal or packing is not in the suction casing. We can pull higher lifts in that configuration. So what are the typical operating parameters on the progressive cavity pump? The pumps have the ability to go from extremely low flow rates, like for metering small or dosing small amounts of chemical, down into the fraction of a gallon a minute range, all the way up over 2,000 gallons per minute. These pumps are commonly used on metering, where it's literally drops of fluid, and all the way up to large flow rates, up into the thousands of gallons a minute range. The pumps can also operate in a wide range of pressures, anywhere from 1 psi all the way up to over 700 psi. Viscosities, we can handle any kind of fluids from alcohol, water-like fluids, all the way up to dewatered sludge cakes, which can be over 1 million centipoise. The pump has the ability to operate in low temperatures down to like -4 degrees Fahrenheit. All the way up to about 350 degrees Fahrenheit. Our limitations on the temperature are the elastomers we use in the stator. Solids, these pumps have the ability to handle extremely large solids. We handle a lot of fluids that have a large percentage of solids, but are very small, all the way up to products that have large, in some cases over 3 to 4 inches size solids. The pump can also handle a mixture of air or gas and liquid as well as solids. So they're pretty unique in that way that they can handle not just liquid, but a mixture of those as well. We can also handle a large percentage of solids, all the way up to about 45% dry solids, which is like a dewatered cake in the wastewater industry. So what kind of flexibility do we have on the installation of these pumps? As we mentioned earlier, the pump can be rotated in either direction. So you can actually change the position of the suction discharge on the pump if required. A lot of the pumps actually use a direct coupled method, so there's no belts, no couplings between the motor, gearbox, and pump. That eliminates any kind of alignment issues. The pump really doesn't care which position it's mounted in. It's pretty common for PC pump manufacturers to mount these pumps horizontally as a standard, but you also see a lot of these pumps mounted in the vertical configuration as well. Most pumps, the suction casing, since it comes in, the suction flange is at a 90-degree angle to the pump. That can typically be rotated in 90-degree increments and can be changed, that position, but can be changed as well. So again, the pumps are self-priming, so a lot of times you'll see these pumps pulling actually a high suction lift. Another component these pumps are used for is metering. They're very low pulsation and very accurate. So you can actually, when using these pumps on metering, you can actually eliminate the need for a pulsation dampener like a lot of the other competitors do on metering. The pump doesn't use any kind of check valves. It actually acts as a valve itself, since there is a compression between the rotor and stator. As the cavity between the rotor and stator progresses out the length of the pump, as one cavity stops, another one's forming. And so it's almost an uninterrupted flow, so you see very minimal pulsations. Again, the pump can handle large solids, as we mentioned, over as high as 4 inches on some of the larger pumps. And because of the way the cavity is formed, when those solids are trapped in the cavity, you see very little damage from the pump. The pumps are used quite often on abrasive fluids. We pump everything from like a calcium carbonate slurry, lime slurry. I mean, products that have quite a bit of solids in them. There is no restrictions once the product gets into the cavity. A lot of pumps have a check valve or some other restricted device in the pump. The PC pump doesn't have anything. Once the product enters the cavity stays the same shape from suction to discharge. We do limit speed when we're handling abrasive solids, just to try to prolong the life of the rotor and stator. And you can also, another method to reduce the abrasive wear on the pump is actually try to limit the slip. So a lot of times we'll do that by either reducing the discharge pressure on the pump or adding stages to the pump so we reduce that slip.
Thank you, Chris. Not all stators and rotors are created equal. Let's take a look at stators first. Oftentimes, I've had to rely on our in-house lab to create new stator compounds. The stator is the sacrificial part of a PC pump, generally wearing out 2 to 3 stators to every rotor. Buna, Viton, Theraban, natural rubber, EPDM, and urethane are some of the compounds that you'll find with PC pump companies. The reason for so many compounds is that there are a variety of operating conditions that can impact the stator, so selection is absolutely critical for success. Chemistry. Aggressive chemicals can cause an improperly selected elastomer to swell, shrink, harden, or disintegrate entirely. When dealing with aggressive chemistry, be careful to select a compatible elastomer. Temperature. High temperature will cause swelling and failure of the elastomer, stalling of the pump, or damage to electric motors from the increase in compression and resulting in high torque. For high temperature conditions, consider an even wall or even a split elastomer design that can allow for expansion. Some PC pump companies have special certifications such as FDA, 3A, even NSF for drinking water. Ask your PC pump company for options. Next, I'd like to introduce my colleague Chris Oakes, who would like to explain more about the characteristics of the progressing cavity pump. Chris?
Hello, my name is Chris Oakes. I am the Applications Engineering Manager at Seepex and have been with the company for 7 years. The municipal market has been my primary focus during my time with the company, but I've also been involved in various other industries including food, oil and gas, mining, and general industrial applications. We would like to share some information with you regarding how PC pump works, specifically the topics of slip and intake efficiency. From there, we'll move on to discuss drivetrain components and power transmission in a PC pump. So what is slip? Slip is the reverse flow of fluid in a pump and is caused by three main factors: discharge pressure, fluid viscosity, and fit. So as discharge or differential pressure in a PC pump increases, slip also increases. As fluid viscosity increases, slip decreases. And as fit or compression between the rotor and stator is reduced due to wear, slip also increases. From the factory, the amount of compression between the rotor and stator has been optimized. So regardless of the source of slip, we must overcome slip to have positive flow. Slip can be detrimental for a couple of reasons. First, slip can cause accelerated wear to the rotor and stator for abrasive fluids. Second, slip actually shears the fluid, which could cause damage to the product. So how do we reduce, eliminate, or compensate for slip? Well, first and foremost, a proper pump selection is key. Our goal is to optimize the pump and its components to meet the application requirements. It should be noted that slip is typically not an all or nothing situation. Some slip is okay in most situations. The most basic way to compensate for slip is to increase pump speed. By increasing pump speed, we overcome the slip and achieve the desired flow. This is actually the case for most pumps that we sell, and is completely acceptable. In situations where we want to reduce the amount of slip in the pump, we often add stages. For example, a single stage pump is rated for 6 bar or approximately 90 psi. If our application requires 80 psi, the single stage is capable, but there may be more slip than desired. So by using a 2, 3, or even a 4-stage pump for this application, we can reduce and nearly eliminate the slip. Eliminating slip and adding these stages will also extend the service life of the pump. Another method for controlling slip is to adjust the compression fit between the rotor and stator. This is less common, but it is advantageous in some situations. Reducing slip allows tighter control for metering and dosing applications. So we should now discuss intake efficiency, sometimes referred to as volumetric efficiency. This is simply a measure of how well the product flows into the pump and fills the cavities. Intake efficiency is affected by fluid viscosity and the pump speed. The thicker the product, the more difficult it is for the product to flow into the pump. Likewise, the faster the pump runs, the lower the intake efficiency. So previously you mentioned that higher viscosity reduces slip. So there's a balance between reducing or eliminating slip and having high enough intake efficiency to actually convey the product. The first method of increasing intake efficiency is to run the pump slower. This means a pump for something like peanut butter will be larger and run slower than a pump for water or other very thin fluid in order to produce the same amount of flow. If the product is very, very thick, we may never reach 100% intake efficiency, and that's okay. In most situations, we can size the pump with some intake efficiency less than 100% and compensate by simply increasing the speed of the pump. Running a little faster allows us to achieve the desired flow. For applications such as a basic transfer of material, we can get away with lower intake efficiencies because they are not near as critical as metering or dosing applications. For these applications, we want to ensure very high intake efficiency such that we have very accurate and repeatable flow rates. Another way to increase the intake efficiency is to force feed the product into the pump. What does this mean? We do this by using an auger in a hopper style pump that pushes the material into the cavities. These augers have a pitch that actually overfeeds the pump, the goal being to completely fill the cavity. Another benefit of this auger is specifically for thixotropic or shear thinning fluids is that the fluid is sheared enough to effectively reduce its apparent viscosity, making it even easier to get the product into the pump. So in summary, we should take special considerations for viscous fluids, but we do have ways of properly handling them. Next, we will move on to the drivetrain and power transmission of a PC pump. The drivetrain typically consists of a motor, gearbox, drive shaft, connecting or coupling rod, universal joints, and the rotor. The challenge in a PC pump is the rotor head rotates eccentrically, while the motor or gearbox shaft rotates concentrically. This means we need some type of universal joints to transmit the torque required to turn the pump. The closed pin joint is the most common universal joint type used due to its simple design and serviceability. It includes an elastomeric cover that seals and separates the fluid from the universal joint lubricant, which is typically a grease or an oil. Pin joints may or may not include bushings, which allow for rebuilding of the joints rather than complete component replacement. Also, proper material selection of the pins and bushings is critical for a long service life. The next type of universal joint in a PC pump is an open pin joint. The open joint is not covered by an elastomeric sleeve and relies solely on the conveyed product to lubricate its components. This is most common in the food industry, such that the pump can be properly cleaned and sanitized. Also used for sanitary applications is the flexible connecting rod made of titanium. This design actually eliminates the universal joints altogether and relies on the flexibility of the shaft to convert concentric motion to eccentric motion. The advantage is that all moving parts are eliminated, but there are limits for speed and pressure. Also, the pump typically is longer to minimize the angularity of the flexible connecting rod. When pumps become very large in terms of flow and/or pressure, the cardan type joint is used. This would be similar to that of a large truck drive shaft that has a dual pin design. Gear joints are also used by some manufacturers, but are much more complicated than pin joints in terms of assembly and serviceability. Finally, we will discuss common PC pump drive arrangements, typically consisting of a motor and gearbox. The block or close couple design is the most common, lowest cost, most compact, and easiest to assemble. The block pump components are all designed such that they easily bolt together and do not require any alignment in the field. In the block design, the gearbox output shaft bearings act as the pump bearings, so they must be sized accordingly. If the gearbox cannot be designed to handle the service conditions, a long couple pump may be required. The long coupled pump includes an integral bearing frame that is capable of handling the pump's full capacity. This design does require an external coupling and increases the pump length, typically by 1 to 2 feet. It goes without saying the long coupled design is more expensive than the block pump, but may be warranted in certain situations.
Thank you, Chris, and thank you all for joining us today. We hope that this short presentation has given you a better understanding of PC pumps. With the ability to handle a combination of high positive and negative pressure conditions, the low pulsation and repeatable flow which saves money on chemical usage, high and low viscosity fluids are easily pumped, resisting aggressive chemistry and high temperatures, all of this while being extremely energy efficient, having less downtime, yet easy to repair when necessary. We believe this to be your best pump solution on the market today. For any questions regarding the content of this presentation, please reach out to any of us on the Seepex team. Thank you all very much again, and good luck.